So, now I will be talking about the state of stress in soils. Do not go to seepage right now, let us talk about the non-seeping flow conditions or dry conditions first to begin with, it is too early.
For the case of when you get the embankment,
yes,
if we can provide a path for seepage to occur,
I will do that. Right now you just think of the basic simple things, try to correlate what you have studied already and how to extend them to a material which is new for you, which is soils, clear. So, once you start mastering these concepts, a stage will come where superimposition of effects will be very simple for you to handle. Those are the effects. Effects can be included in the system very easily. At this point, what is happening? Oh, the end effect of all these forces at this point is there is going to be a normal stress. I write normal stress as sigma, and there is going to be a shear stress. I write it as tau. So, the question number 1 is, when we say state of stress in soils, can we find out sigma and tau for as a function of external forces? Is this okay? And this sigma and tau is always on a plane. Why? Because I am interested in understanding the detachment of a block from the parent body, and this plane gets created because of the criticality which we are talking about in the soil mass, and the condition is each and every point within the soil mass is going to be critical simultaneously. Fine. So, sigma tau acting at alpha. So, plane indicates alpha value and then there has to be a point. So, point O, external forces and alpha. Is the statement of the problem clear? I can modify this as sigma x, sigma z. Now, you might say why not 3-dimensional? Again my answer would be let us do first 2-dimensional cases which are more prevalent in engineering, because most of your structures are 2-dimensional in nature, though they appear to be 3-dimensional. Why it is so? Embankments, soil mass, they are all extending up to infinity in the third direction, is it correct? So, we are taking a slice of this, and hence a 3-dimensional problem is being converted into a 2-dimensional problem. And once you become an expert in solving 2-dimensional problems, you can extend them to 3-dimensional problems easily. That is not a very difficult thing. So, sigma x, sigma z, what else is going to come? Tau xz, very nice. What else? Alpha. So, what I have done, all these forces, external forces, I have converted them into stresses. In geomechanics, engineering sciences and engineering technology, we do not talk about the force ever, we always talk about the stresses. Though the forces are acting on a system, we convert them into stresses, alright, and then we put them over here like this. So, what I am interested in is, I am interested in finding out sigma and tau as a function of sigma x, sigma z, tau zx, alpha. This is the state of stress which is existing at a given point, and this point lies on the plane at which the failure is going to take place. Okay, let us start this process. I will isolate this whole system now and go for the free body diagram of this. It is a point and point is lying on a plane, correct. So, suppose if I say that this is the point O and this is the plane 1 1, and on this plane the normal stress and shear stress are acting, clear, and then we have combination of sigma x and sigma v. So, what I have done, all F1, F2, Fn I have combined in sigma x and sigma v. So, truly speaking, sigma x is your horizontal stresses divided by area of cross section, and this is also equal to vertical stress divided by area of cross section. So, henceforth we will not talk about this V and H. As I said, we normally do not talk about the forces, we talk about the stresses. Now, if I take the projection of this plane and if I assume that this plane extends up to unity in the third direction, clear, and this is of unit length and this is also unity. So, area of cross section is 1. So, area of cross section of this is 1 is square 1. If this has the angle of alpha, this is going to be, the horizontal force is going to be now sigma x multiplied by sin alpha, and this is sigma v multiplied by cos alpha. Can you do simple equilibriums? And try to prove that tau will be equal to sigma x minus sigma z by 2 into sin 2 alpha, and sigma will be equal to sigma x plus sigma z by 2 plus sigma x minus sigma z by 2 into cos of 2 alpha. This is what is known as the equilibrium equations, and these are known as 2 alpha equations. I hope you can realize that if tau is this and sigma is this, truly speaking, this is the form of equation tau square plus sigma square equal to a square. And this is nothing but a circle. That means these equations are the generalized form of the circle which is known as the Mohr circle. Okay. What we have done in last 3 minutes, and Mohr circle onwards you are aware of everything in the mechanics you have done. So, now soil does not appear to be a foreign material. Now, we can handle it easily because strength of materials is already done and you started with Mohr circles. So, I have brought down everything to the Mohr circles and I will be using this as a tool to define the state of stress which is getting induced in the material causing failure because of the external forces, distresses. And what is the assumption? It is a rigid body. So, we are not talking about any type of deformation, settlements, compression now, it is the 100% shear failure. This is a simplified solution which we have obtained for this type of a free body diagram. Here I have taken this as the radius, so you can interpret it the way you want, and then this is tau and sigma. So, what he is suggesting is I have not taken into account this thing. I am just coming to that. Good that you have hinted on this. So, this equation is valid provided your sigma x is sigma 1. You know what is sigma x equal to sigma 1 and sigma z equal to sigma 3. So, if this is the condition which I am assuming over here, where this happens to be the major principal plane, principal stress, and this happens to be the minor principal stress, Now I think your question is answered. And by virtue of being this sigma 1, sigma 3, sigma x, sigma z, tau zx tends to 0. So what I have done? A complicated problem I have further resolved into a situation where sigma x, sigma z happens to be the minor and major principal stresses. That means there is no shear stress which is going to act over here. So your point is correct. If I want to generalize this thing, I will have to show a shear stress component here, and I have to show a shear stress component over here, and this is what is going to be tau xz. We need not to enter into these complications at all. I will tell you why. Because what I have done is I have created a subset out of this, and if I can define this circle where sigma 1, sigma 3 correspond to tau and sigma, this is going to be a solution to a problem which I can generalize further on. So this is the situation where you have this is as sigma 1 and this is as sigma 3. So what we do is we plot it as a function of tau and sigma on the tau sigma axis. This is the center O. So by virtue of this, it becomes sigma 1 plus sigma 3 by 2, the coordinate of the center, and the radius is sigma 1 minus sigma 3 by 2. So this is the coordinate of the center and this is the radius.